Hi, I'm Everett. Welcome back to the shop. This is part two in the, basically it's making a rear main seal installation tool for a Paccar MX13 heavy truck engine. As I said before, they're kind of expensive to get here, take a little while to ship in as well. So my boss has asked me to make him one, and so we're partway through that process. Again, hope you find it interesting. So now the outside here we have to turn down to, well, pretty much 4.5 inches even. That's making it work, that's for sure. Like I say, I don't want to go all the way to the back. It's breaking a chip, but it's working for it. Now, what's its diameter? 4 inch 975. We have a ways to go yet. Let's leave it about 15 thousandths for the final touch up on that shoulder. Oh, for Pete's sake. I really don't like birds' nests. Yeah, we're half thou over 4.5 inches, so that is good enough. Now we're going to flip the part. Oh, right. Flip the part. And we'll clean up the other side. Alright, so it's pretty much close to matched. So now we're going to use the compound and put a slate chamfer on the front end. Well, taper, I guess. There we are. So that's the pilot the pilot that will go in the center of the install tool. I'm happy with it. So the next step is we have to drill the holes in the plate here. We're almost done. We just have to drill the holes in the plate. I did run into one snag though, and that is the fact that because my rotary table, it's an 8-inch rotary table, and the part that is, well, 7.5 inches, just, you know, it's not going to work easily to just, you know, slap it on there and stick it down with hole downs, because I can't really get them through easily. And the holes I need to drill are 11/16 for the big holes. So what I'm going to have to do is I'm going to really just be using this for layout and spotting. Once I get this done, then we're going to move it over and, you know, just drill it on some blocks, I guess. So what I've done already is I've located the center of the rotary table to the quill. Already dialed that in. Table's locked that way. They then set the disc of the press tool, the seal press tool, in here, and then indicated around this inside ring. Now, so the rotary table is concentric with the quill. The plate is concentric with the quill. Now what we need to do is just lay out the bolt hole circle. Now the bolt hole circle itself is 5.5 inches center to center. So what that gives us is 2.75 radius. So I'm going to leave the Y locked. We will now gently unlock the X, and now that we have our backlash out, there's our 0. We'll have to count out 27.5 turns. We'll go that way. Seven and a half. All right, so now that we have we're theoretically 2.75 inches across, we're going to center drill this. Right, yep, that's right over top the slot. So we can poke a pilot hole through that one. There we go. Now, we should have, theoretically, a 5.5 inch bolt hole circle. Which, that's pretty much bang on. And we measure edge of hole to edge of material. 940. $940. Good. Okay. We're laughing. All right. Theoretically, we should be able to spot this one. Good. So these ones are going to get drilled all the way through with the 3/16 as a locating pilot. Now, one last hole that we're going to mark out, we're not going to drill all the way through simply because of the fact that I want to mark up my table, is the fact that there's a small nub on the back of the crankshaft, and it is 15 degrees off of one of the bolts. There. Two-inch 60. 2-inch 60. Ha! There we go. So yes, we're not drilling that one all the way through. But now that we have this laid out, we are going to pull this out so we don't lacerate ourselves. Don't really feel like doing that right now. We can unlock our table. We can break this down. So we've pulled the table off, got the plate now clamped down on some 123 blocks to provide some clearance. That way we don't make any other authorized modifications to the mill table. And now we can line up with the pointer. And truthfully, this is going to be close enough as it is. The holes are actually 17 millimeters in the crankshaft, but we're going to use the 11/16 just to give a bit more clearance. This one here is, like I say, the little stud is 10 millimeters across. So we're going to use a letter Z drill, because that's just a little bit bigger. There's that one. There. I mean, yes, I know a person can indicate on holes and such, but I really don't want to do that for this. We're going to open it up first a little bit with a 7/16. There. Now that I've actually used Morse taper drill bits a little bit, I actually prefer using them. Sometimes all you got is Silver and Deming. Reduce shank. Yeah, one could use a bit of a sharpen, couldn't it? There we are. 3 more of those and we're golden. There we go. Hole number 4. Well, 4 of the big ones anyway. Well, apart from the deburring, there is the pressing plate. Deburr that, and then we can press the center hub in. Take another bite. Yep. So she protrudes a little bit on the backside, that's fine. That will work just nicely. Well, I hope that was at least somewhat interesting for you. Again, it's one of those things where, you know, you help a buddy out when you can, and it just so happens he's also my employer. So, yeah, it fits. I'm pretty tickled with how it turned out overall, and yeah, and it saves us a pile of money as a company. So, thanks for watching. Thanks for subscribing. If you haven't subscribed, thanks for coming by. It's good to see you. Thanks for wanting to come by. Thank you all for comments you make, the thumbs ups. I mean, it all makes a difference. Any of us small producers, whatever, here on YouTube, every little thing like that's a perk me up for us. So thanks for everything, everybody. I'll see y'all next time.